get our first question. If the vector x has component 4, 1, and the vector y has component 4, 8, 6, are parallel, we will find the value of a. So the condition is that, they are parallel vectors. And our parallel vectors, what are they? They have the ratio of their corresponding components to be the same. So let's get the ratio of their corresponding components. That means the ratio of the s components, 4 to 1, to 4a is equal to 1 to 6. That is the ratio of the corresponding components. So when you take these are the x components and these are the y components, their ratios should be the same. Now, this is a common mistake. Assuming we wrote, 4 to 4a as the first ratio, and now in writing the second ratio, you rather made it 6 to, let's say, 1. The moment you do it like this, you've changed the order of arrangement. So that is what you're supposed to know. So this is not equal to, this is wrong. So always take note of that. Now, we have 4 to, 4a, and then 1 to 6. What do we do to find the value of a? Ratios can be expressed as fractions. So we're going to get 4 out of 4a, and that is equal to 1 out of 6. That is what we have. And easily we can do cancellations. 4 can cancel, ACF1, it can go into this one. So we're getting 1 out of a equal to, 1 out of 6. So at this point, we can just do cross multiplication. That is, we just multiply the 6 by 1 and then a by, 1. So a times 1, that's going to be a. That is equal to 6 times 1. That is 6. Let's get our second question. If the vector p has component 7, 4, and the vector q has component, 14, 3x minus 12 are parallel, you have to find the x. That is what we're going to do right now. Now let's begin. Okay, so the fact that the two vectors are parallel means that the ratio of their corresponding components are equal. Now let's get the corresponding components. Remember, the vector p has components, 7, 4, and that of q also has components 14, 3x minus 12. So they are parallel. That means the ratio of their corresponding components are equal. So let's get our corresponding component. So that's going to be 7 to 14. That is the ratio of the x component. Is the same as the ratio of the y component. So that's going to be 4 to 3x minus 12. So that's the ratio of the y components as well. Now, from here, we just, change the ratios to, common fractions. And that's what we're going to get. We have 7 out of 14 equal to, 4 out of 3x minus 12. At this point, let's see if we can simplify. 7 out of 14, we can simplify. So let's do that cancellation here. So 7 into this is 1, and it goes into 14 2 times. So that means I'm going to get 1 out of 2 equal to 4 out of 3x minus 12. So that is what we're supposed to get. So at this point, what do? We can just do cross multiplication. So 1 will multiply 3x minus 12, and 2 will multiply 4. So we're going to get 3x minus 12. That is 1 times this. We're going to get the same thing. That is equal to 2 times 4. That is going to be 8. So at this point, we can add 12 to both sides. So I'm going to get 3x minus 12 plus 12 equal to, 8 plus 12. And I'm doing this so that I can do away with this, minus 12. So this one can do away with this one now. So we have 3x equal to 20. Now what do? We just divide here by 3, here 2 by 3. So this one cancels this one. And now this implies that x is equal to, 20 out of 3. Which is the same as 6 whole number 2 out of 3. Because 3 times, 6 is going to be 18. 18 plus 2 will give you 20. So that is the final answer. If the vector m has component 1 minus z, so m has component 1 minus z, 3. That of the vector n has component 2z minus 3, 1 are parallel. That's the condition. So we are using the same idea. The ratio of their corresponding components of parallel vectors are the same. That means that, from the first vector, the s component is 1 minus z to, 2z minus 3 is equal to 3 to, 1. So these are the ratio of the corresponding components. They are equal. Now let's write them as common fractions. So 1 minus z we're going to get this out of 2z minus 3. Now, you should know that these are binomials, so they can be kept in bracket. Yeah. Now, it is equal to 3 on 1. So what do we do next? We have to do cross multiplication. So once you multiply this one, so we're going to get 1 times, 1 minus z equal to 3 multiplying 2z minus 3. So this is what we have. Now, let's expand to remove the bracket. So 1 times 1, we're going to get 1. And 1 times next z, that's going to be next z. And that is equal to 3 times 2z, that's going to be 6z. And 3 times neg 3, we're going to get neg 9. So this is just a simple linear equation. So we have to balance the equation to find the value of z. So I want to get rid of this minus z. So I'm going to add, z to both sides of this equation. So that's going to be 1 minus z equal to 6z minus 9 plus z. Don't forget, I am adding, z to both sides just to do away with this z. So let's see what we're going to get. Now we've been able to achieve our aim. Next z will cancel this one. So we have 1 equal to. Now, these two guys, they are like terms, so we can group them. So we have 6z plus z, minus 9. So at this point, we are going to get 1 equal to 7z, that is 6z plus z, minus 9. So what do we do next? Don't forget, we have to find the value of z. So we have to do away with this, neg 9 by adding 9 to both sides. That's going to be 1 plus, 9. And that is equal to 7z minus 9. So when you simplify 1 plus 9, that's going to be 10. Equal to 7z. And now, neg 9 plus 9, they are going to erase each other. So that's what we have. So we just divide here by 7, here 2 by 7. So 7 will just cancel this 7. 7 cannot go into 10, and there is no number that can simplify the two guys. So this implies that z is equal to 10 out of 7. Or if you want to write it in mixed fraction, that's going to be one whole number, 3 out of 7. So that is how we can find the value of z for this particular question. So let's get this interesting question. 3 vectors a, b, and c are given by 1, 3, 2, 5, and 5, 15 respectively. That means the vector a has components 1, 3, the vector b has components 2, 5, and that of the vector c has components 5, 15. So these are the vectors, and they are asking us which of the two vectors are parallel. That means two of the vectors are parallel. So how do you know that the vector a and b are parallel, that of, let's say, b and c are parallel, or let's say a and c are parallel? So we're going to do these combinations, and you see the two vectors that are parallel or which are parallel. So let me start with the vector a and b. Now we know that for vectors to be parallel, then the ratio of their corresponding components must be the same. So let's get this one. For the vector a and b. So that means that 1, 2, 2 should be equal to 3 to 5. So we can see that these vectors are not parallel. If we still disagree, let's just write them as fractions. We're going to get 1 out of 2 is equal to 3 out of 5. In fact, this is not true. 1 out of 2 is not the same as 3 out of 5. So they are not equal. And because of that, the vector a is not parallel to the vector b. They are not parallel. They are not parallel. Let's come to, so this one didn't work. Let's check a and c. Now when you compare the fractions, the vectors a and c, let's get the ratios of their corresponding components. Now we are going to get 1 to 15, 1 to 5. Yeah, 1 to 5, that is the x for a, that of for c. So 1 to 5, and it should be equal to 3 to 15. We have 3 to 15. Now let's write this one as fractions, and we're going to get 1 out of 5 equal to 3 to 15. I think we can prove further. We can simplify 3 here 1, 3 here 5, and that's going to be equal to 1 out of 5. So it means the two vectors, they are parallel. because the ratio of their corresponding components are equal. So for A and B, and C, they are parallel. Let's get the last one. Okay, so for B and C, you have the vectors B and C here. Let's check the ratio of their corresponding components. So I'm going to get 2 to 5, and it should be equal to 5 to 15. 5 to 15. I hope you are not confused. So now we can write them as fractions, and we are going to get 2 out of 5 equal to 5 out of 15. Now when you simplify, we're going to get 2 out of 5 equal to 5 here 1, 5 here 3. So we have 1 out of 3. And unfortunately, they are not the same. So the ratios are not equal. That means B and C are not parallel. This is very, very interesting. So we can conclude that the vectors A and C are parallel vectors. Thank you for watching.